Hello, and welcome to the physics lab. Today, we are going to talk about the visible spectra of hydrogen. Why do I have such strange students? The visible spectrum of hydrogen. Now, the good news is you only have to take 5 data points. 5 data points. The bad news is, depends on which kind of a piece of equipment you get, what you have to do. Because we have different sets of equipment. Today, my assistant, Amanda, will demonstrate how to use all the equipment. Because she knows exactly what to do, right? So demonstrate how you measure the visible spectrum of hydrogen. Now, if you get one of these setups, help me lift this up here. What you have to do, just lift it straight up, is make sure that your light is on some books like that. Because otherwise, it's not up high enough. All right? You're missing. Get closer to. There we go. If you have one of these setups, you don't have that problem. You have other problems. And you probably have a lot of problems. Okay? So now what you do is you start off by focusing your lens here. And this takes 2 things. You have the objective and the eyepiece, just like the compound microscope. And you have to focus them. See, this moves here, and this comes loose and moves here. And you focus it on something across the street. Okay? So we'll pretend we already did that. You want to focus the lens and the crosshairs. You want to make sure it's focused on it. Then what you do is you look through here, and you find. I messed it up.
Yes, well, sounds like it.
I messed it up. I believe I messed it up. You find the line. Go ahead, take a look, man. See if you see it?
Yes.
Okay, see, we both agree there's a line, so there must be a line because we would never lie.
Of course not.
Okay? And then what you have to do, and we're going to have detailed instructions on this. I'm not going to give them to you now because it's going to depend on which station you get, and I don't want you to watch both of them. On how to loosen things up. You have a fine adjust here and a lock here, so you can move it like this. But then you have a little fine adjust on this side, for example, on this one. And what you want to do is you find that and you center that line on the crosshairs, and then you loosen this gap here and you set your 0 precisely. Okay? You see this? See this 0 here? That 0? You want that 0 and the 0 to match up precisely. Okay? You got me? All right. I just moved it.
But if you put your object closer than it,
Then we tighten that one down.
3 of them.
That locks at 0. Now on this one here, it's a little bit different. Because
And they should come out.
somebody locked this thing on, I can't get it off. Jeez, can't get a good lab assistant anywhere, can I? There we go.
Yeah, where you
Okay.
you have to be.
This one's a bit more difficult. So what you do here is you find the line again. You do the same thing with the lenses. You focus on the thing across the street. You find the line again. Go ahead, find it. And you don't drop the lenses on the floor. That was the other class. Can't get good. You find it? Okay. Now the problem here is setting the 0. The way you do this is you look for the red line, and you're gonna. I guess we're gonna have to have the gradient in place to do that. Greg, when we 0 this one here, we have to put the lens in the gradient in place, right?
You can
An expert
0
consultant.
without the grading, put the grading in, and then
But we
use
don't
the gradient.
But we don't have the red lines until.
Well, you have, no, the central maximum, the pink one of
Yeah.
the hydrogen, is there without the
Okay, so then we 0 it.
diffraction gradient.
You 0 it.
Because I think, whoops.
Loosen that up.
Oh no.
Move this thing around. There, it's 0. Okay. Now, the next part is to add the gradients. Again, it depends on which one you've got. If you have one of these, if you look on it, it'll say down on it, or maybe just some scribbled writing somewhere like that. The down side goes down.
Did you have to read that?
All right, and you might want to come over here so you can see that.
Rating average of 3.
I see now. I remember. Now the hard part here is you want to make sure that this is perpendicular. Now I remember what I did wrong.
The distance of the image.
To the lens here.
Sure.
Now how do you do that? Well, that looks pretty good. Now you need to put this cover on. And then what you do is you're going to have some lines that you see. And what you want to do is you want to look for the red line. So you go look in here and you find the red line. You just pretend it's right there. See, isn't it right there?
Oh,
Say yes.
yeah, definitely, yep.
Okay? And you read the number off of it, and it says 27.3 degrees. And then you go over here, and you find it over there.
Oh, yep, definitely.
And now it only says 23.8 degrees. So you're not quite right. So you have to adjust this until those two numbers agree. Okay? That way you know that your grading is perpendicular to... The benefit of this one is you can read off the numbers. The angles are read in degrees and tenths of degrees and so forth. Now on this one here, it's easier to put the grading on. Come on over here. See, I would even trust my lab assistant to put the grading on here. See this? Don't drop!
Oh, okay.
Ah! Okay, and you put it in there. Very good.
Good job, Amanda.
That was hard. And now what you want to do here, now you're sure this is going to be perpendicular. That's the good news. The bad news here is this guy doesn't read in just degrees and tenths of degrees. He reads in degrees, minutes, and seconds. You have to convert that to degrees and tenths of degrees and so forth. The other bad part about this is
Oh, you did take it on that.
for this to work, this one here, we're going to have to turn the lights off. All right? For this one. That one over there, the other one doesn't need the lights off. What are you going to expect? This is antiquated equipment, right? Come on.
Did it click it?
We are on video here.
Might want to
Focus on him. Focus on him for a second.
Which one?
All these guys over here.
He's the one swearing. I didn't say anything. I said,
All right. So then you go and you look on through here and you get a red line, like right there, and a blue line or something. I can't remember the colors right now. You get all the lines and you write down the colors. Now you're gonna have to read the directions about how to get the measurements off of this thing here because it's not as straightforward as you might think. And then when you get your measurements, you type them all in, and 5 data points later, you're done with the lab. Sound like a good idea?
Yep.
All right then, I will see you in the physics lab. The secret code, I forgot. The secret code. What's a good secret code?
Tofungus.
No, we used tofungus already. Shish kebab is boring.
Banyo sucks.
I'm gonna have to bleep that one out.
Santa Monica.
What? Oh, actually, I got a good
Santa
one.
Monica Cup.
No. Dislocated shoulder. Dislocated shoulder. In honor of the first person in the physics lab, any physics lab, probably anywhere, to ever dislocate their shoulder in a physics lab. So I'll see you in the physics lab.